Okay, so one more application here. In this case, we're going to be throwing a football up into the air, and it's going to obviously go vertically up in the air, and then we know it's going to come back down. And it turns out that the height of the football, we'll call that h of t, in feet, for some given time t, given in seconds, is given by this formula. So again, I'm giving you the quadratic function that mathematically models the ball coming up and down. Okay? And so what they're asking us for to begin with is to find the maximum height of the ball. Well, since this is a quadratic function, we are looking basically again for the vertex. But unfortunately, right, we're not in standard form. So we basically have to find that vertex, and we can either complete the square or we can use the vertex formula. And I'm going to go ahead and use the vertex formula. So we know that negative b over 2a, right, is going to basically help us find that vertex. In this case, my b is 180, and my a is negative 16. So for starters, a negative divided by a negative is a positive. I know that 2 goes into 18 9 times with a 0. So we have 90 over 16 at the moment. And if we continue to reduce this, I know 2 will go in that, and 2 will go in that. We get 45 over 8. So we're basically looking at, I think if 8 goes into 45, we'll bust out some calculators in a moment. I think 45 goes into 8. What is that? 5 times 5 and 5/8 seconds is what I'm basically getting there. Okay, so there you have that. And of course, if we go to a calculator, let's go ahead and get a decimal approximation. 45 divided by 8. All right, we get 5.625 seconds. Now we got to be careful here, right? Because all I have found is the h. What they're wanting is what is the maximum height of the ball. So that's our k value, and we find that by plugging that h value into the function. And I'm kind of overabusing h. This h means height. This h over here means it's our value. So sorry about that. Kind of overabusing some stuff there. So we got negative 16, 5.625 squared, right, plus 180 times 5.625. Right, and again, I'm using the calculator on my computer, so I think we end up getting 5.625. I'm going to square that, and then I'm going to multiply that number to negative 16. And when I do the work here, what I'm getting, this first number here is a negative 506.25. And then we're going to add, when I take 180 and multiply it to 5.625, right, what we get is 1,012 and 50. So subtract the 506 from that, and I'm getting 506.25. So 506.25. So there's our vertex. There's our k value. So what is the maximum height of the ball? 506.25, and this is measured in feet. What time does it reach this height? 5.625 seconds. So according to that model, right, there's basically what we get. So 5.625 seconds to reach its maximum height, and then 506.25 feet is the maximum height as it comes back down. And of course, that's my next question, right? At what time does the ball return to the ground? So if it's returning to the ground, this means that my height is equal to 0. So again, we're in effect finding x-intercepts. So we got to take my function. So this is the next part. This is part C. We got to take our function, negative 16t squared plus 180t, and we got to set it equal to 0. I'm thinking probably the best way to do this guy is to factor. I think 4 goes into both of these. So if I factor out a 4, I know that's a negative 4t actually. That's a negative 4t. And let me check, 4 into 180, that's 4, 16, 20, 45. All right, so we get plus 45 equals 0. So using the zero factor property, 4t is equal to 0, or negative 4t plus 45 is equal to 0. And so if we divide both sides by 4, one of the times that it's on the ground is at time equals to 0. So that makes sense because that means at the very initial, right, we basically shot the ball upwards from ground level. So at the beginning, it was at ground level. It went up 5.625 seconds. It reached its highest point, and then it came back down. And so if we subtract 45 from both sides, the value we get from here is where it comes back and returns to the ground. Divide both sides by negative 4, and we get t equals 45 over 4, which I believe is 11 1/4. I don't need my calculator for that. So 11.25 seconds. So basically the flight of the ball, when you guys take a physics class, you'll realize that the 180 is the velocity. So somebody fired this football up in the air at 180 feet per second. So if that happens, right, it's going to take 5.625 seconds to reach a maximum height of 506 feet to 0.25 feet. And then after 11 1/4 seconds, 11.25 seconds, we should observe the ball hitting the ground again. So it starts at the ball, reaches its maximum height, comes back, returns to Earth, if you would, a little over 11 seconds later. So again, that idea of finding an x-intercept, in this case I used factoring to find it and get the job done. There's other ways to solve quadratics, but this one happened to factor really well. You can complete the square, you could use the quadratic formula, all kinds of different ways to get the job done. So there's your applications. Lots of good stuff with quadratic functions. We'll actually see more in later work, but we'll save that for another video, and we'll save that for another section. As usual, if you guys need help, right, you guys need to email me, right, jump on Canvas and start asking questions, right, or see me for an office hour. You can either see me for the office hour or set up an appointment. Whatever it takes to help you get the math down. Talk to you all later.